Now we'll take a look at vector operations. So just like when we have numbers or functions, we can add, subtract, multiply them by a real number, etc. So we want to investigate if we can do those with vectors. And we'll start doing these vector operations graphically. So consider some vector v, and we call CV, where C is some real number. It can be negative too, but we'll start where C is positive because it just makes it a little bit easier. So we call that a scalar multiple of the original vector. We can sketch CV by drawing a vector with the same direction as V, but with a magnitude that is C times as long as that original length of the vector. So it sounds a little more complicated than it really is. So if I'm given this vector V, and the instructions are to graph 2V, that just means I need a vector that is twice as long as V, but has the same position. So pointing the same direction, but just twice as long. So I'm going to pick a place for it to start because remember, the starting and ending positions are not what makes a vector, right? It's the magnitude and direction. So let's say I plan to start my vector right here. And if I draw 1V, it would end, say, at this point right here. So that would be the length of 1V. But since I want 2V, then I'm going to tack another length of V onto that. So this is the length of just V here, but I can start a vector here, and this one is going to be twice as long. It's almost like you're going to take that vector and stamp it, right? You're going to stamp it twice, but just leave the arrow on the end of the last one. Now, what if I wanted to graph, say, negative v? So now we're introducing multiplying negative numbers by the vector. Well, consider negative v as just negative 1 times v. So the magnitude is the same, meaning same length. So it has the same length as this original vector, but the arrow is going to point in the opposite direction. So thinking of putting it on the opposite end of the original vector. So think of putting the arrowhead on the opposite end. So let's give that a try. So if this is V, well, I'm going to draw those same points. So kind of think of it like slope, up 2 over 3. Okay. So these are those points. And it's going to have the same kind of line segment here, but the arrow instead is going to be on this end, pointing in the opposite direction. And we can call this negative V. Okay, let's keep going. Now we can add two vectors together. And again, we're just looking graphically first. And the sum of two vectors is done so that the terminal point of V coincides with the initial point of W. And then the resulting vector V plus W is the vector whose initial point coincides with the initial point of V and whose terminal point coincides with the terminal point of W. This is one of those things where describing it in words is more confusing than just kind of saying how to draw it out. So if we're doing V plus W, I'm going to draw V at just some position where there's room. So again, I just put those 2 points there because it kind of guides where my line segment should be. And I call this V. And then where does W go? It's just saying W should start where V just ended. Okay, so then I'm going to take my W. I'm going to start it, so where that point, where this vector ended, I'm going to start W, and then it's just going to end where it would typically end. Okay, so this is W. And then the vector V plus W is just going to be, let me redo that one here so it starts at the right spot. Okay. So it's just going to be the vector that starts at V and ends at W. Does that make sense? So it starts at the starting point of V and ends at the ending point of W, and this vector is V plus W. Now, can we subtract these vectors in a meaningful way? Yes, and the easiest way to do that is think of subtraction as the inverse of addition, meaning V minus W is the same as just V plus a negative W. Okay, so now it says, knowing that, use these vectors below to graph U minus W. Okay, so what I'm going to say is I'm going to say that's the same as U plus negative W. And that's going to make it easier for me. So I'm going to start out with U because U says just graph me regular, and this is just some, graph paper that we're using here. So U is up 3/1. So it doesn't really matter where I start U, but if you're unsure where it's going to end up, you could kind of start it in the middle so that you kind of make sure it doesn't get messed up. Okay, or go off the graph. So here's U, and then it says add a negative W, and I'm like, I'm not quite sure what negative W looks like. Well, I could just go over to where it's drawn typically. Like, wouldn't negative W just be pointing in the exact opposite direction? So wouldn't it just be like this? Right, this is negative W. It still has those same kind of, points where you're kind of going up to, left to, but this time the arrowhead is on the other end, so it's pointing backwards from where W is pointing. Okay, so now when it says add negative W, it's really just saying add this arrow. So what that does is just says put this arrow where U ended. So if U ended here, that's where W is going to start. And W would start here and end here, so it makes a nice little arrow. I'm going to call this negative W, and then to actually draw in my resulting arrow, again, wherever I started, U, right? U is my start, so I'm going to start here, and then wherever negative W ended there, that's going to be the start and the stop for my vector. And I'll label it over here, U minus W. And so we can see that doing these vector operations graphically is not so easy. These ones kind of like worked out really nicely. For ones that are a little funnier, we're going to need to know how to do vector operations symbolically, and we'll do that next.